So for lesson 7, we're going to look at some new lines, or some new angles that are formed by two new lines that we haven't talked about yet, which are secants and tangents. The opening exercise in the circle below, attempt to sketch 3 lines. One line that intersects the circle once, one that intersects the circle twice, and one that intersects the circle 3 times. So we can do, very simply, there's an intersection of 1 time. There's an intersection of 2 times. So those are pretty straightforward. But then this one here intersects a circle 3 times is not possible. Okay, so you can either intersect the circle 0, 1, or 2 with a line. You would need some sort of curve to be able to intersect it 3 times. So only those first 2 are possible. So a couple new things, a secant line. So both of these lines are going to be involving a lot of exterior parts of the circle. So a secant line is a segment, it could be or a line. So a segment / line from the exterior of the circle that intersects the circle twice. All right. So an example of a secant line would be something like that. All right. You'd have 3 points, the 2 that hit the circle and then the 1 outside. You could continue it past and it could go through the circle on both sides, but that's probably the most generic way that you see it. And the tangent line is basically the same thing. Okay. So it's a segment or a line from the exterior of the circle that intersects the circle. Now, this time it's only going to intersect once. Okay. And a lot of the times you see it drawn kind of like that. All right. Again, it could go through if it wants to. Okay. So when it only hits it once, it never actually goes inside of the circle. Okay, so really it just touches the circle in one spot and never actually goes outside or inside, excuse me. So a new rule that's kind of not a new rule, an angle formed by the intersection of a chord and a tangent will equal half of the measure of the intercepted arc. So now if you take a look here, if we want to find angle X, it looks a little bit like an inscribed angle. Now, an inscribed angle would be made by like a chord and a chord, but it's going to follow the same rule as the inscribed angles. Okay. So if we look here, given tangent CD, determine the measure of X if Y is 320 degrees. So if the arc that X opens up to is 320, then X is going to be half of that, which is going to be 160 degrees. All right. Same picture, but now they make us work a little bit more. So in the circle below, the measure of minor arc AC is 4A, and the measure of major arc AC is 14A. And we want to determine the measure of X. Well, first we have to deal with these 2 arcs. Since those 2 arcs make up the entire circle, we know when we add them together, we're going to get 360. So 4A plus 14A is 18A. Divide both sides by 18, and you get that A is 20. So what does that leave us here? 4A is then 4 times 20, which is 80, and 14A is 14 times 20, which is 280. All right. So now if we look, X is going to be half of 280, which is going to be 140 degrees. All right. So like I said, kind of looks a little bit like an inscribed angle and actually acts exactly the same way. So now this is the rule that really is kind of more important. An angle formed by the intersection of 2 secants, 2 tangents, or 1 tangent and 1 secant is equal to half the difference of the intercepted arc. Okay. So now when we talk about the angle here, we're talking about letter P. All right, so all those angles that are formed outside of the circle. All right, now, and here's the rule. So the angle is going to be equal to, we usually say big arc minus small arc divided by 2. All right. Now, when we talk about the arcs here, they have to be between the secants or between the secant and the tangent, stuff like that. So if you look here at the first one, what would be the big arc? Well, the big arc would be CD. The small arc would be AB, all right? Because again, those are the ones between. Arc AC and arc BD are useless to us because they are not between the two secants. So here, the big arc would be from A to C. The small arc would be from A to B, and then that arc at BC would be useless. Now, when you have two tangents, you'll see there actually is only two arcs. There's the big one, and there's the small one. All right, so those are easy because there's only actually two arcs. But this angle equals big arc minus small arc divided by 2 is something that we kind of want to commit to our memory. So exercise 3 says 2 secants intersect outside of a circle to form an angle of 42 degrees. The larger of the two intercepted arcs measures 168. Determine the measure of the smaller. So it's kind of hard to do these without a picture. All right. So we're going to draw a circle, and then it says 2 secants. So that means we need to draw 2 lines that are going to intersect the circle twice. And I'll draw them so they look like that. All right, obviously your picture can be a little bit different. So it says the angle formed outside of the circle is 42 degrees. And the larger of the two arcs is 168. Now, obviously the larger one is always going to be the one that is further away because those secants are always going to have that same shape. It wants us to determine the smaller arc. All right, so if we look again here, I'm just going to bring it up in 2 pages so we can see the last one. Our rule was angle equals big arc minus small arc. So angle equals big arc minus small arc divided by 2. Now, when you're searching for the angle, it's easy. You do the subtraction, you divide by 2, no problem. When you're searching for one of the arcs, though, you're going to end up putting the angle over 1, and you're going to cross multiply. So when you cross multiply, you get 84 equals 168 minus x. You'll subtract that 168 on both sides, and you get 84 minus 168 gives you 84. That was easy. There we go. So where negative 84 equals negative x, we divide by negative 1, and x will give us a positive 84 degrees. All right, so we'll be 84 degrees for that smaller arc. As we go here to our next one, I'll go back to my single page here. 2 tangents intersect outside of a circle to form an angle of 80 degrees. Determine the measure of each intercepted arc. Now, these tangent ones, they can make a little bit tricky for a particular reason. So if we draw 2 tangents, they intersect normally kind of like an ice cream cone. So they'll look kind of like that. Now it says the angle outside is 80 degrees. Now in the last one, they gave us one of the arcs, and that's how we were able to figure out the other one. The difference in the tangent problem is that there's only 2 total arcs. So it's kind of up to you how you work with this. If I were you, what makes this a lot easier is I always call my smaller arc x, and then if there's only one arc left, the other one has to be 360 minus x. All right, because it's a circle has 360 degrees, so it's always 360 minus whatever that other arc is. So we're going to set up our same thing. So our angle is equal to big arc, so 360 minus x, minus the smaller arc, so minus x over 2. Now again, all of our x's are in our fractions, so we're going to end up cross multiplying. So 80 times 2 is 160. Here, we're going to do negative x and negative x to get 360 minus 2x, okay? We will subtract 360 on both sides. That will give us negative 200 equals negative 2x. We'll divide by negative 2, and that will give us that x is 100. Okay, so what does that give us here? That gives us a 100 degree angle for the smaller one, and then 360 minus 100 gives us 260 for our bigger arc. Okay, so that's a rule that only applies to tangents. You couldn't do that same philosophy with any of these problems that involve secants. So exercise 5 has a couple more challenging ones. What I'd like you to do is pause the video and see if you can solve these on your own before you watch how I do it. So we have to be careful when they have a lot of binomials in them, but we'll follow the same rules. Angle, so 3x plus 17 equals big arc, so 21 plus 19x, minus, now we have to subtract the whole smaller arc, so we got to put that in parentheses, divided by 2. All right, we'll end up putting this over 1. So when we cross multiply, what we need to do is we have to distribute that minus sign. So we end up with 21 plus 19x minus 31 minus 9x equals, and then here we're going to have to end up distributing that 2 to the 3x plus 17. So as I do that here, I'll combine my like terms. So 21 and negative 31 is negative 10. 19x and negative 9x is a positive 10x equals 2 times 3x is 6x, and 2 times 17 is 34. Okay, so now we'll look to solve. I will plus 10 and minus 6x minus 6x. So that's going to give me 4x equals 44. I'll divide both sides by 4, and x is 11. So it says solve each for the value of x and determine the measure of the angle outside the circle. So then we do 3 times 11 plus 17. Well, 3 times 11 is 33, plus 17 is 50 degrees. So we get that x is 11 and that the angle outside is 50. Same philosophy. So we are going to be 15x equals big arc, so 55x minus 2 minus small arc. Now we don't need parentheses here because it's just a number. So minus 48 over 2. We'll put it over 1. So we can just do this negative 2 minus 48. So we get 55x minus 50 equals 30x. We have to subtract the 55x on both sides. So that's going to give us negative 50 equals negative 25x. Divide by negative 25, and we get that x is 2. So now if we want to find out what the angle outside is, 15 times 2 gives us 30 degrees. So we get an x value of 2 and an angle of 30. And the last one here, so we are 7x plus 5 equals 35x minus 2 minus 93 over 2. So again, we're over 1, we cross multiply. So we can do the subtraction again. So 35x minus 95 equals, and we'll have to distribute here. So 2 times 7x plus 5. So I'll just bring down my 35x minus 95 equals 14x plus 10. So I will subtract 14x, and plus 95 plus 95. So that will give me 21x equals 105. Divide both sides by 21, and you get that x is 5. So our x value is 5, which means our angle outside is, well, 7 times 5 is 35, plus 5 is 40. So then we end up with a 40-degree angle outside. So you can see basically what this comes down to is these are actually more challenging problems than what you're likely to face. But you have to remember that that angle outside the circle is going to be equal to the big arc minus the small arc divided by 2.